Hi guys, welcome back to my YouTube channel. Welcome. Today we'll be talking about energy balance. Yes, but before we move right into it, if this is your first time watching this video or you just stumbled on the channel, please kindly hit the subscribe button. And if you've subscribed already, thank you for doing that. But please remember to like, comment, subscribe, and share to people that you know that will benefit in this video. So let's get right into what we have for today. Energy balance, like I said. So the calculations that are related to energy balance, that is what we want to talk about. But before we jump right into it, we need to know some things like the formulas that we use for solving our calculations. So let's move into it. Energy balance. The principle of first law of thermodynamics, conservation of energy, forms the basis of energy balance. That's just trying to let us know that is the principle of first law of thermodynamics. And yes, I've talked about first law of thermodynamics. You can check them up. You can check it up in my page. Yes, you will see them. So it talks about the principle is the one that forms the basis of energy balance. And first law of thermodynamics is that energy can neither be created nor destroyed. So the formula is delta E in the system over delta T equals the rate of heat minus the rate of work done plus summation of mass flow rate inlets, then into brackets enthalpy E plus velocity square in divided by 2 plus G plus Z in minus summation of M out into brackets enthalpy out plus velocity square out divided by 2 plus gravitational force Z out. Now this formula is when the system or when the um, system basically is an unsteady state. Yes, then is in an unsteady state. But when the system is in a steady state, this is what we have. Unlike when velocity is zero, when the kinetic energy is zero, when the thermal energy is zero, and when the potential energy is zero. So we are left with our mass and the enthalpy. So which brings us to Q minus W equals to summation of M out H out minus summation of E M in H in. And our M is the mass flow rate in kilogram per hour. Our H is the specific enthalpy in kilojoule per kilogram. Our Q is the rate of heat, which is in kilowatts. Our work done is also our W is the rate of work done, which is also in kilowatts. So just like in conservation of mass, I've talked about conservation of mass too, and the video is up on my page. You might need to check it out if you have not. So just like in conservation of mass, E in equals to E out. So in conservation of mass, we have sorry, this should be summation of E in equals to summation of E out. So in conservation of mass, we have summation of M in equals to summation of M out. So now said, and in E out, the E out could be the product, the waste, the stored matter, and the stored material and losses. So which implies that when energy is like the whole energy that goes into a system after probably processing, after mixing, when you have your product, it might not be the same energy that entered the system that would come out. But at the end of the way, if you check well, probably the energy was lost or it was stored or energy wasted. But at the end of the day, the inlet should be able to be equal to outlet. So the ones that you cannot figure out, the energy that you cannot figure out, so that's our energy loss. But some of the energies might be stored, some might be waste. Yeah. So since our E out could be all of this, so we can say some E in is now summation of E in is now like EP plus EW, ES, and EL. And our EP is product, waste, stored materials, and our loss, which makes up the whole E out. So these are the formulas that we'll be using Basically, this in steady state. We're not talking about the ones that are in unsteady state. So the one in steady state and the energy balance equation. Basically, the reason why the unsteady state is there is because it forms the basis of these equations. So let's move right into the question. A bakery oven heats a stream of bread dough from 20 degrees C to 80 degrees C. The mass flow rate of dough is 1.5 kilogram per second. The specific enthalpies are H in, which is 250 kilojoule per kilogram, and H out, which is 750 kilojoule per kilogram. So now said calculate the rate of heat transfer to the oven. Assume no work is done. So let's write out our values. Like I always say, the first thing, write out your values. So T1 now is 20 degrees C. T2 is 180 degrees C. So the mass flow rate of the dough, which is our M dot, is 1.5 kilogram per hour. Sorry, it should be per hour. So that won't convert per hour. So the specific enthalpy is H in 250 kilojoule per kilogram and H out 750 kilojoule per kilogram. So we have the formula Q minus W equals to M change in this. So we have all our known values, all the values that are needed. So we just need to input our values into the equation. So we have what's our Q? That's what we are looking for. Rate of Q. Said they assume there's no work done. So that means our W should be 0 since there's no work done. What's our mass? 1.5. Our enthalpy is H out minus H in, which is now Q equals 1.5. What's H out? 750. What's H in? 250. So this is 1.5 multiplied by 500. So we have 750 kilowatts, and that's simple as ABC. But remember, there's a formula that says summation of mass out and H out minus summation of mass in H in. So this formula is actually what they deduce to this. So Q, it should be Q minus W equals this. So if they have the same, a common mass inlet, or if they have a common mass, so that's why we now have M. Since M is common, we have H out minus H in. I just decided to just chip that in just for reference purpose. So that's how we got this formula. So to let's move to our next question. A food processor mixes a stream of yogurt with a stream of honey. So we now have two feed now. The mass flow rate of yogurt is 2 kilograms per hour, and the mass flow rate of honey is 1 kilogram per hour. The specific enthalpy of honey, H in, is 300 kilojoule per kilogram. The specific enthalpy of yogurt, H in, is 250 kilojoule per kilogram, and the H out is 400 kilojoule. Sorry, the H out of both. Assume there is no work done. Calculate the rate of heat transfer to the blender. So in this case, we have the same. I said the same. We have two feed that is being processed into the processing machine. So we can use our formula of summation E in equals E out. Now before we can calculate this, okay, let's write out our values. Since we have to, let's write separately. You got, we're giving for products, and the H out um, on, and we have products. So for you got, we're giving mass flow rate, which is 2 kilogram per hour. For honey, mass flow rate, which is 1 kilogram per hour. Specific enthalpy of honey, 3,000. Is it 3,000 or 300? Should be 300, sorry. Kilojoule per kg. Then for yogurt, it is 250 kilojoule per kg. Then they now said the H out, the products, is 400. But we can also get our mass flow rate for products. Since two different materials are going in, and we know the mass for each of them, and whatever mass is going in should come out. So since we know that we have two mass flow rates, 2 and 1, so our mass for products would be 2 plus 1, that's 3. So 3 kilogram per hour. Now we can use this formula. Now if we want to use this formula, which is E in equals E out, we know that our formula for E is Q minus W, mass delta H, right? So this is like we are saying for inlets mass 1, or let's say for Y and H, then H2, HY, let's say HY, then let's use Y, because this H would, okay, let's just use mass 1, mass 2. So this is H1, H2. Don't forget both of them are actually inlets. So since we have this formula and they said our work done is 0, so that means we are left with Q equals to mass flow rate change in theta. But so that means our Q1 means for inlets now. Let's say Q inlet will now be M, that will be Q equals M1 H1 now, then M2, that should be plus, this is the summation, M2 H2. So this is for inlet, then to be equals to Q outlet too. But since Q is common between them, that must be equals to M3. Let's call this one 3. So that's M3H3. So we have Q equals, what's our M1? So what's our H1? 250. What's our M2? 1. What's our H2? 300. What's our M3? 3. What's our H3? 400. So our Q will now be equals to 500 plus 300 equals to 1002. Then Q is now 800 equals 1002. So Q is 800 minus 1000, which will now be equals to minus 400. So our Q is minus 400, and the minus is just to let us know that it is giving out to the surroundings. So let's move to question 3. A bakery oven heats a stream of bread dough from 20 degrees C to 180 degrees C. The mass flow rate of dough is 1.5 kilogram per second. The oven does 12 kilowatts of the work on the dough. The specific heat enthalpies are H in, which is 200, and H out, which is 400. Calculate the rate of heat transfer to the oven. So what are the values that we're given? Our temperature, which is T1, T2 180 degrees C, mass flow rate of dough 1.5 kilogram per hour. The work done. Now, since it's the oven that is doing the work, that means work is done on the system, so it's still going to be positive. So 12 kilowatt. Specific heat enthalpy H in is 200 kilojoule per kg, and H out is 400 kilojoule per kg. So we have to calculate the, and we know that our minus this is going to give us a, so this is what we are looking for. We are given this to be 12 kilowatts. What's our mass? 1.5. Then out minus in, that's 400 minus 200. So we are left with Q minus 12 equals 1.5 times 200. So Q equals to, Q minus 12 equals, that's 300. So our Q is 300 plus 12, which is 312 kilowatts. Yes, and that's all. So let's move to the last question on energy balance. A food processor compresses. Okay, so from the word compresses, you know that our work done will be negative. That's if work is done. Compresses the system. So if you don't understand what I just said, it has been detailed in first law of thermodynamics. So check up the video on first law of thermodynamics. This thing has been well explained there. A food processor compresses a steam of air to mix with a steam of flour. The mass flow rate of air is 1 kilogram per hour. The compressor does, okay, so work is done. That will be minus 10 kilowatts of work on the air. The specific enthalpies are H in equals 200 kilojoule per kg, and H out is 300 kilojoule per kg. So calculate the rate of heat transfer. Where's my, so our Q minus W is mass flow is in H. Our Q is what we are looking for. What's our W? Minus 10. What's mass 1? 10. That's 300 minus 200. This is Q plus 10 equals 1 times 100. That's Q plus 10, 100. Our Q equals 100 minus 10. So Q is 90 kilowatts. And now we've come to the end of the calculation under energy balance. If you have any question, please drop them in the comment section. I will definitely give answer to your question. Please do not forget to subscribe, like, share, and comment. Share to your departmental groups and to people that you know that this video is going to benefit. Till next time, see you guys later. Bye.